Hi everyone, welcome back to the GCSEMathsPro YouTube channel. In today's live, we'll be going through the June 2019 Paper 3 Higher Tier Calculator paper from Edexcel. Make sure that you've got your calculators with you, the ones that you will obviously be using in the exam as well, preferably. I've linked in the description this paper so you can have a look at that. You can open it and download it yourself, or you can also find the mark scheme in the description as well. So let's just make this a little bit bigger. So question 1, we have Venn diagrams. As you can see, this kind of little squiggly, what looks like an E shape, just represents the universal set, and the universal set, as you can see it's also here, is basically just the whole Venn diagram. So whatever's in the circles, whatever is outside of the circles. So that tells me that my whole Venn diagram should have the numbers from 1 to 9 somewhere in it. We've got A more specifically and B more specifically. So I just like to go through the list of the universal set and then just check where each of them are. For example, the first one is number 1. I can see that that is in A. I can cross that off. Number 2 is in B, and so on, just carry on. Now number 3 is not in either of them, so that goes on the outside. The same with number 4 on the outside. Number 5 is in A. Number 6 is in both A and B, so that goes in the middle. Number 7 is in neither of them, so on the outside. And then 8 is in A. And finally, 9, you can see is in both as well. So I'm making sure that I'm ticking off not just the ones that are in A and B, but also the ones that are on the outside. So that would be 3 marks just to literally fill in that information. Then we've got a number is chosen at random from the universal set. Find the probability that the number is in the set A intersect B. We've got this kind of N shape. That's just A and B. When it kind of looks like an N shape, doesn't it? A and B. That's how I remember it, because it looks like an N. That's where they overlap, where they intersect. So that is this section here. So if they've chosen a number at random from the universal set, they've chosen it from the whole Venn diagram, right? So that means that you can see that there are 9 numbers in the whole Venn diagram. So out of 9, how many are in the overlap? 2. So it should be 2 9ths. That's your probability of picking one from the middle. So a nice 5 marks to start with for that one. Question 2, we've got Katie invests £200,000 in a savings account for 4 years. The account pays compound interest at a rate of 1.5% per annum. Calculate the total amount of interest, underline that, interest, Katie will get at the end of 4 years. So this is just a really straightforward compound interest one. So just use your formula from the formula sheet unless you already know it. We're going to start with obviously our principal amount, which is the 200,000, multiplied by 1 plus the interest rate over 100. So you can write that if you like in brackets, or if you know how to make it into a decimal, it's just 1.015, and then to the power of the time, which is 4 years. So I'm going to put that in my calculator first. So 200,000 times 1.015 to the power of 4. So we get £212,272.71. But in this case, because that's why I obviously underline the interest, they've actually asked for just the interest. This is the figure that Katie will have at the end of 4 years, but it includes the original 200,000. The interest is just the amount of money additional that's been added. So obviously you just want to subtract it. You can obviously see what the answer would be from there, but just write it down to get the method marks. Subtract the principal amount, the starting amount. So you can see you should just get £12,272.71. I normally round to 2 decimal places just because it is money. Okay, so that's your 3 marks for that one. So question 3, the table shows information about the heights of 80 plants. Find the class interval that contains the median. So the median is the middle number, isn't it? They're obviously in size order, as you can see by this column here. 80 plants, so what is the middle of 80, or effectively half of 80? That is the 40th plant. So think about this in order. Where would number 40 lie? Well, here is the first 7 of them. Then if I add 13, that's the first 20 plants, isn't it? So still not that in either of these two. Then this one here would be the first 34 plants, so still not enough. And then these all together would be the first 46 plants. So this one was up to 34, wasn't it? 34. This one's up to 46. So you see how number 40 would be in this row here. And you just copy down that exact information there. Between 40 and 50. That's where our middle plant would lie. Now for part B, on the grid, we have to draw a frequency polygon for this information. So let me copy my table just so that we can see it all in one place. Get rid of all this. There you go. Obviously you'll be able to see it just anyway on your page, but just so that I can zoom in enough. Now frequency polygons is the one where you do plot midpoint. Cumulative frequency is the one where you don't plot the midpoint. Okay, you don't plot the midpoint. This one you do. So obviously midpoint of 10 and 20 would be 15, and then up to 7. Be careful of the scale. Can you see on this y-axis, it's kind of a difficult scale. So I think 2 squares would represent 1. So that's 1, that's 2, that's 3, you get the gist. 4, so every 2 squares is 1 in terms of frequency. So 7 would be 4 squares above the 5, so here. Not even there, on the midpoint here. There we go, 15 and then 7. The next one, the midpoint is 25 and then 13, so 6 squares above 10, and you get the gist, so on. 35 for the next one, up at 14, so that's 2 squares before 15, and then 45 up at 12. You get the gist here, so 55, 16, and 65 finally at 18. Now with a frequency polygon, because it kind of has to look like a polygon, so like a shape basically, we want to use our ruler and draw straight lines between them. So kind of like jaggedy straight lines, connecting them up. Something a bit like this. You don't join up like the top and the bottom ones, you just leave it open like that, so it's at least still a graph. Okay, so that would literally be it for your frequency polygon, just straight lines joining them up. So question 4, Sean has drawn a time series graph to show the numbers in thousands of visitors to a fun park. Write down 2 things that are wrong or could be misleading about this graph. So just have a look at kind of all the axes, how they're labelled, the numbers, all of that to see if there's anything wrong. One of the things that I thought was if you have a look on this y-axis, you've got 6, 6.5, 7, 7.5, 8, so on. It goes up in 0.5, doesn't it? But here, we're missing. They've gone straight from 9 to 10. So you could say that 9.5 or some version of this is missing from the y-axis. Or it goes from 9 to 10, you know, some kind of version of referring to this point here. The other thing that I saw was each 2016, 2017, 2018 seemed to have 2, 3, and 4. So they've got numbers for each. That's got 3, that's got 3. But the first one for 2016 has got a number for 4, a number for 3. It doesn't have a number for 2, does it? So I just put something like 2016 is missing a point plotted on x is 2, something like that. Okay. Anything that you can kind of think of that is missing, basically, or is just not to scale. So here for question 5, we have the diagram shows a hexagon. The hexagon has one line of symmetry, which you can kind of see, obviously would be roughly down the middle, wouldn't it? Somewhere about here. They've told us, and obviously you can see on the diagram, FA is equal to BC and EF is also equal to CD. And then the angle ABC is 117. We've got that to start with. The angle BCD, so this one, is equal to 2 lots of the angle CDE. So you can see that this is a smaller one, isn't it? So what you could do if you want is label that the smaller one X, that would make this one 2X. And then because there's a line of symmetry, then it's the same on the other side. This would be 2X, this would be X, and based on that line of symmetry as well, this angle would also be 117. So at least now I've labelled all 6 angles. And it says work out sides of angle AFE. AFE, so this one here, the 2X. So I normally use the formula n minus 2 times 180. That tells me the amount of angles, or like degrees, in any polygon. So obviously for a hexagon, you might know it already, but most of us won't have memorized how many degrees are in a hexagon. So that's n is representing the number of sides, right? So 6 minus 2 times 180. That gives me 720. So I know that this should all add up to 720. So now you can create an equation. You've got 2x plus 2x plus x plus another x plus 117 and then another 117. And then that should equal 720. And then it's just solving it from there, isn't it? So you've got 6x plus 234 is 720. Obviously, I'm going to subtract the 234 to get just 6x, which leaves me with 486. And then if you divide by 6, you get 81. Now, the only thing to bear in mind, though, is that I know that it feels like you found the answer when you found x, but this one isn't just x. That's not the answer, is it? We were looking for AFE, which was 2x. So just remember, is x actually my final answer, or have they asked for something more than that? 2 times 81, so 162 should actually be your answer. And you can see that one was 4 marks. Question 6, Jeremy has to cover 3 tanks completely with paint. Each tank is in the shape of a cylinder with a top and a bottom. The tank has a diameter of 1.6 meters and a height of 1.8 meters. Jeremy has 7 tins of paint. Each tin of paint covers 5 meters squared. Has Jeremy got enough paint to cover completely the 3 tanks? We obviously have to show our working as well. So the context of this is surface area. Sometimes it's volume, sometimes it's surface area, because we're covering the outside of the tank. So surface area. So the surface area of a cylinder is, well, of any shape. You're just adding up all of the areas of all the sides. So because this one, it says it has a top and a bottom, that means it has 2 pi r squared, 2 lots of the circles, plus, and you need to know how to work out the area of the kind of bit around the cylinder. If you were to unravel that, imagine like a can of beans or something, if you were to take the label off, this bit here is still the height, isn't it, the 1.8, that's fine. But this bit here, it's a rectangle, would actually be the circumference. So 2 pi r or pi diameter, whichever you like to use. So we're going to add 2 pi r multiplied by the height. So that's basically the formula. You don't need to memorize it, you just have to kind of build it up when you're working it out. That's the formula. Now, also double checked because they have given us the diameter, which our formulas mostly use radius. So remember to change that. So we've got 2 times pi times 0.8 squared plus 2 pi 0.8 on its own times 1.8. So that would be the surface area of our cylinder. So let's work that out. 2 pi times 0.8 squared plus 2 pi, put some brackets in actually just to make sure it works, times 0.8 times 1.8 . Now, as you can see, it is a really kind of long digit number, so I'm going to use the pi version, which is 104 over 25 pi, because this isn't our final answer yet. So that's the surface area, but that's of only one of them, isn't it? I actually want to have 3, so I'm going to have to multiply this by 3. It's meant to be a 4. Multiply it by 3. Again, I'm going to leave it like this because, actually, no, let's convert it to a decimal now because we're actually towards the end, aren't we? So 39.207 roughly. 39.207, and that was meters. Oh, I put centimeters, but that was meters squared, wasn't it? Let's get rid of that. Meters squared. Now, how much paint does Jeremy actually have? He has 7 tins, and they cover 5 meters each, 5 meters squared. So that's 35 meters squared. So he needs 39.2. He's got 35. Does he have enough to completely cover the 3 tanks? Well, therefore, no, he doesn't, because he needs 39. He's only got 35. So just a bit of surface area there. And as you can see, that one is 5 marks, so quite a big question. Question 7 is a really nice one. It's just one of those kind of calculator use ones. So we just need to type in all of this to the calculator. So the square root of 2.5 times sine 43 over 8.2 squared minus 50.5. So what I would do, I know it says give your answer correct to 3 significant figures. What I would do is, I'll move this over here a little bit. See how we've got 2 marks there? I think I would write down maybe this bit here, at least all of the digits, just to get some kind of working out almost, and then I'll round it. So that is 0.3191419,855, and then round it to 3 significant figures, which is just 0.319. So yeah, just write something in the middle there just to get that second mark for the method. Question 8, we've got ABC as a right-angled triangle. Here is Sarah's method to find the length BC. So this one here. So she's done BC squared is AB squared plus AC squared. Sub them in. She subbed them in correctly, that's fine. In terms of AB is 6 and AC is 8. She got 100, so BC is 10. But what mistake has Sarah made in her method? Well, it's obviously been kind of rotated, but if you look at BC, if you were to label it, obviously with Pythagoras, is A squared plus B squared equals C squared. C is always the hypotenuse, isn't it? So she's thought that BC was the hypotenuse. This is actually the hypotenuse, isn't it? That's the diagonal one, or the one that's opposite the right angle. So this can be A and this can be B. Those don't really matter. But something along the lines with she's basically used the wrong side, or she's put it in the wrong order. I would say she has used BC as the hypotenuse. Which it's not, is it? You could say in brackets if you wanted AC as the hypotenuse. Some version of that is fine. Or she's, maybe subbed them in incorrectly in terms of the order of the formula. Some version of that is okay for 1 mark. Now, there is a part B to that question, not to do with Pythagoras at all, but just kind of in terms of finding out errors. So Roy is going to enlarge triangle PQR with center C, scale factor 1.5. He draws triangle XYZ. Explain why Roy's diagram is not correct. My first thing is the center and the expansion, because he's followed the lines, that looks fine, doesn't it, in terms of it's got further away from the center. So my second thing is to just look basically at the scale factor and count it. So originally we had, let's say on this side, 2 sides, 2 squares, and then here we have 1, 2, 3, 4, 5. And then originally here we had 4, and here we have 2, 4, 6, 8, 10. So what is the scale factor there? Well, it's not 1.5, is it? 'Cause 1.5 would make it 3 by 6. He's actually used, you can obviously divide it in your calculator if you want, but scale factor, you could say 5/2, you could say 10/4, that would obviously simplify as well to 5/2. Scale factor 2.5, isn't it? Or in other words, 5/2, not 1.5. So that's what's wrong. It's not the correct scale factor. Question 9. A company has to make a large number of boxes. The company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. The table gives the number of machines working each day. So if you had all 6 every day, it would take 9 days. But you can see here we've only got 3 on one day, 4 on the next day, 5 on the third day, and so on. Work out the total number of days taken to make all the boxes. So this is our inverse proportion one, where obviously the more machines you have, the less time it takes, the fewer days it takes, or vice versa. If I have fewer machines working, it's going to take me longer. So I like to work out, well, how long would it take if I just had one machine? And that's the opposite of what you might think. You might think, oh, I'm going to divide it, but no. Think about it. If I only have one machine, it's going to take 6 times longer. So 54 machine days, isn't it? There's 54 machine days in total. Now, go through day by day. That's if I only had one machine working each day. On the first day, I actually have 3 machines working. So that would account for 3 of these days, wouldn't it? Because it's 3 times faster. So what I can do is go, right, 54 minus 3. After day 2, that's 4 days, isn't it? Because if I've worked out that it's only one machine for 54 days, then it's going to be 4 times faster, obviously, for day 2, and then the same thing, 5 times faster for day 3. So subtract all of those to see how many days or machine days you have left. That gives me 42. And then all the other days are 6. So obviously if you divide that by 6, that gives me 7. Now, the answer isn't just 7, don't forget though, because yes, it's 7 days as in afterwards, but we have had the first 3 days, haven't we? So don't forget that it is 7 plus 3. So 10 days in total, actually. That's how many days it would take. But I found that was quite a tricky one out of this type of topic. Question 10. Marie invests £8,000 in an account for 1 year. At the end of the year, interest is added to her account. Marie pays tax on this interest at a rate of 20%, and she pays actually £28.80 in tax. Work out the percentage interest rate for the account. So this is just reverse percentages, we're just going backwards. So if I know that £28.80 is equal to 20% of my interest, I want to work backwards to find out the interest first of all. So do you see how that would be reverse percentages? I have to divide. So my interest is equal to 2880 divided by 20%, which obviously 20% is a decimal because you have to put it as a decimal on your calculator, is 0.2. Should put decimal there. And make sure you type it in properly. Is £144. So that's how much interest that Marie got. Then it was only for 1 year. It sounds like compound interest, but it's only for 1 year. So compound interest only works when it's more than 1 year. So don't think of it as compound interest as such. It's just literally just a percentage for 1 year. So I want to know what percentage 144 is of the 8,000. So working out as a percentage, just divide it by 8,000 and obviously times by 100. So 144 divided by 8,000 and then times by 100 is 1.8. So it's 1.8%, and that's literally it. 1.8%. Question 11. In May 2019, the distance between Earth and Mars was 3.9 times 10 to the power 7 kilometers. In May 2019, a signal was sent from Earth to Mars. Assuming that the signal sent from Earth to Mars travelled at a speed of 3 times 10 to the power 5 kilometers per second, how long did the signal take to get to Mars? So this is obviously, standard form, but also speed, distance, time. So we're looking for the time, so you can see I need to take my distance, 3.9 times 10 to the 7, over the speed, 3 times 10 to the 5. And I'll just type that into my calculator literally as it is. .9 and then 3. And you can see we get 130. They haven't said about leaving it in standard form or anything, so I'm just going to write 130 seconds. That makes sense there. Then for part B, the speed of the signal sent from Earth to Mars in May 2019 was actually less than 3 times 10 to the power 5 kilometers per second. How will this affect your answer? Think about it. If the speed is less, you can just say, okay, well, if my denominator is less, this is the way I think about it. You can think about it in different ways. But if my denominator is smaller, if I'm dividing by a smaller number, then my answer will be bigger. But also you can think about it in terms of the context. If my speed is slower, it's going to take me more time, isn't it? So either way, I would say something like, it will take longer, or your answer will be bigger, or it will take more time, something along the lines of that is okay. Question 12, Patrick has to work out the exact value of 64 to the power of a quarter. Patrick says 1/4 of 64 is 16. So 64 to the power of a quarter is also 16. Explain what is wrong with what Patrick says. So hopefully this is mostly a non-calculated question normally, but fractional powers are actually roots. So this would be, so you can say something like, you can always, when it says what's wrong, you can always correct them. You can say, he should have worked out, and this is the type of root is obviously that number, so the 4th root of 64, which is 2. It's not a quarter, it's literally just like rooting it in terms of the power of 4 there, which is not 2, is it? It's 4. Wait. Let me see what it actually is. Maybe it's a decimal. Yeah, it's a decimal number. It's 2.8. So yeah, don't need to write the answer because that's not actually a whole number. Okay, question 13. The density of ethanol is 1.09 grams per centimeter cubed. The density of propylene is 0.97 grams per centimeter cubed. 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of antifreeze. So density mass volume, we need this formula, density is mass over volume. We have got the density of each, we've got the volume of each, so you see how that's the only thing that's missing is then the mass of each of them individually. So that's what I'd work out first. I'd work out the mass of, let's put E for ethanol, would be the density 1.09 multiplied by the litres, 60, the volume. Which should give you 65.4. That's obviously in grams. Then I do the same for the other one, propylene. Then the mass of propylene would be 0.97 multiplied by 128, which gives me 124.16. And then, therefore, I could work out the total mass of the antifreeze, couldn't I? That would be both of those added together. Yeah, I don't know. I mean, if you found this one easy, then that's good. So adding those together, we get 189.56. Now I have got the total volume as well, haven't I? I've got the total volume of the antifreeze was 188 litres. That's grams. So do you see how now I could work out the density of the antifreeze is mass over volume? So that's 189.56 over 188. I'll type that in so you can see. We obviously need to round it as well. So they've said 2 decimal places, so I would round that to 1.01 because obviously the 8 makes it round up, doesn't it? 1.01 is how I would round that. Now let me make this bigger. Okay, question 14. The diagram shows a rectangle ABDE and 2 congruent triangles AFE and BCD. So they're identical triangles, these two. The area of rectangle ABDE is equal to the area of triangle AFE plus the area of triangle BCD. They've given us this ratio, AB to AE is 1 to 3. So normally I like to write that in terms of like x and then 3x. You don't have to, but I like to do that. So let's say this side is x. Write it better than that. This side here is x, this side here is 3x. Work out the length of AE. So what I would do is, they've given you an equation, haven't they? So I'm already thinking, like, even if I'm not really sure what to do on this one, I'm thinking, right, how can I set up that equation? Which is why I've used x. So the area of the rectangle is obviously just x times 3x. So that'd be 3x squared on the left, wouldn't it? Is equal to both of the triangles added together. Now both of the triangles are identical, so it's basically 2 lots of one triangle formula. But we don't have any version of the perpendicular height, so I'm not going to use base times height over 2, and also they have given me an angle. Now don't start thinking that this is a 90-degree angle, because I know it kind of looks like it, but they haven't actually told us that it is. So we can't assume that it is, right? So I'm going to use the trigonometric area formula. So half is obviously on your formula sheet, half AB sine C. Now obviously you can relabel these sides if you want to match it with the formula if you find that helpful. But basically it's the angle and then the 2 sides between, isn't it? So that would be 2 lots of, it's the same triangle, a half times 24. Now again, using CD, well, what was it, BD or AE, I'm going to use the 3x. So I needed to label it somehow. Sine of the angle between them is obviously the 30 degrees. So I'm just setting up a formula like that. That's kind of my thought process. From here, I can just see what I can do to solve it. Obviously 3x squared. A half times 2 is just cancels out, doesn't it? So we've got 24 times 3, I guess. And sine 30, because this is a calculator, you can obviously type it in, is also a half. So you end up with 36x on this side. If you simplify all of that, I can show you. Obviously, can't type the x in, but if you type in like 2 times a half times 24, that's a 1, 24, times 3 times sine 30. Do you see how I get 36? So I've just basically simplified all of that right-hand side. Now, you could, if you wanted, because it is a quadratic, you could move it across, make it equal to 0, factorize it into one bracket. Or you can just go, well, if I divide by 3 on both sides, that means x squared is equal to 12x. But I could also divide by x, right? So you could do it that way, or, I'll show you the other way, is if you moved it across, you'd get this. Obviously, even though it's a quadratic, it's not a completed quadratic, so I'd only be able to pull out 3x minus 12. Do you see how you'd get, obviously, two solutions? Technically, x is equal, well, 3x is 0, so x is 0, which it can't be because it's a side length, so that one's just like invalid. Or x minus 12 is 0, so x is 12. You could do it that way. You could do it either of these two ways, whichever one makes sense to you. This is a either or scenario, but either way you get x is 12. Now just double check what was the question, because they asked for AE. X is actually, let me rub this out. X is actually this one's 12, but they've asked for this vertical one, which is 3 times 12. So do remember to check, was it actually x that they were asking for or something else? So 36 would be your answer. Yeah, it's just building an equation and figuring out also mostly the triangle bit, which formula for triangles can I use. But I think because it had an angle and you didn't have a perpendicular height, it had to be the trig one. Yeah, a little bit of a tricky question, that one, but yeah. Okay, let's make this bigger as well. So question 15. The graph of the curve C with equation y equals f of x is transformed to give the graph of curve S with equation y equals f of negative x minus 3 on the outside. The point on C with coordinates 7, 2 is mapped to the point Q on S. Find the coordinates of Q. So you can do it kind of one at a time. There's obviously two transformations here, isn't there? So the first one I would just look at is the negative x. When it's just a negative, there's kind of technically no numbers. That's going to be some form of reflection. When it's next to the x, it means it's affecting the x coordinates. So technically you would think of it as a reflection in the y-axis, but it affects the x coordinates. So what that tells me is, if I would, you'd have to write it like this, but just to kind of show you. If it was just that, it would make it just negative 7, and the 2 would stay the same because it's only one transformation. It's only affecting one of those coordinates. And then let's add in the minus 3. Minus 3 just on the outside. If it's a number that's plus or minus, it's some kind of translation. So left and right, up and down. Because it's on the outside of the bracket, it means y-axis, and the y-axis is always the correct kind of logical direction. So minus 3 does mean down. So we still got minus 7 on x. That now doesn't change. We're only now affecting the y. Take away 3 from 2, you get minus 1. So that's your answer, minus 7, minus 1. So just break it down piece by piece. Normally, each one transformation will affect only one of the two coordinates at a time. So first was affecting the x coordinate, then the second one was affecting the y coordinate. So that's 15. Question 16 is a nice one. We've got, here are the first 6 terms of a quadratic sequence. -1, 5, 15, 29, 47, and 69. Find an expression in terms of n for the nth term of the sequence. So I have a specific way to do this. You might have a different method to me, so you just stick with whichever method makes sense to you. You don't have to do it the way that I'm doing it. But I normally obviously work out the first difference. So you've got 6, and then 10, 14, 18, 22. Obviously, because it's a quadratic sequence, none of these are the same. So then we have to go and work out the second row of differences. which should be the same. You can see 4, 4, 4, 4. And then I just memorize some formulas. So equations 2a is equal to the 4. It's always equal to this second difference, whatever it is. So then I can solve that to get a is 2. Then I move on to 3a plus b is equal to the first difference. It has to be on this left-hand side, right? Specifically, so this one here is equal to 3a plus b. Now, because I already know what a is, you can just substitute that in, and then you've got an equation with just b. So in this case, b would just be 0, wouldn't it? That just means there isn't a b value. That's fine. And then finally, a plus b plus c, again, working along that left-hand side, is the first actual term in the sequence. And because I know a and because I know b, I can work out c. So I've got 2 plus 0 plus c is -1, so c is -3. And now what do those represent? an squared plus bn plus c, just sub them in. So 2n squared. Because b is 0, there just isn't a bn for this one. That's fine. So I'm just going to skip straight to -3. Let me just check the comments. What's the formula for this, and will you get it on the formula sheet? You mean the quadratic sequence, this one here, question 16? Or which question are you referring to? I didn't see when you sent the message, sorry. If it's the quadratic sequence, then no, you don't get any of that. You just have to memorize this formula, or if you've got a different, well, not formula, it's not even really a formula. You just have to memorize this method, or if you've got another method, then you can memorize that one. But no, this is not on the formula sheet. So the things I've highlighted, 2a, 3a plus b, a plus b plus c, those three I just memorize. And then I know that they're equal to the left-hand side, kind of working. You see how you're working backwards as you go up that way. Yeah, exactly. Always 2a is always this second difference. 3a plus b is always the first one of the first differences. It has to be on this left-hand side as well. It can't be 10, it can't be 14, it has to be on the left-hand side. And a plus b plus c is always the first term in the sequence. Obviously, I had to start kind of going backwards because you couldn't start at a plus b plus c, because if you don't know a and b, you can't work out c. So you have to kind of start over here and then work your way across. So yeah, remember these three here. 2a, 3a plus b, a plus b plus c. That's what I do. I know there are different ways to do it, but I just find this easier personally. Yeah, I think that there is a chance that this could come up on paper 3 because it hasn't come up yet. There is a chance. So this is definitely a good one to kind of memorize, because it is just a case of, if you memorized it, it's just methodical. You just go step 1, step 2, step 3, and you always get the answer if you do it, you know, following a method. So quite a nice question, I think, if you've memorized these 3 things that I've highlighted, right? The yellow, the orange, and the blue, and you see it's all on the left-hand side, just working backwards, kind of upwards. So yeah, quite a nice one, I think. So yeah, make sure that you've taken note of that, and because it might come up in paper 3, we'll see. It hasn't come up yet, so there's a good chance. Okay, some graphs here. Just make it a bit bigger so we can see. So here are 4 graphs. The graphs represent 4 different types of function f, so don't really need to worry about what that means. That's just f of x, you can see. Match each description of the function in the table to the letter of its graph. So f of x just represents y, right? So you can think of it like that. Is inversely proportional to x. We've got, one is that it's a trigonometric function, so a trig graph. One's an exponential graph, and one is directly proportional, but to the square root of x. So 3 out of 4 of these are graphs we should have memorized. I would say the last one, I probably personally wouldn't know, but if I can get the other 3 correct, then it's just whatever's missing, isn't it? It's kind of process of elimination. So inverse proportion, you should know the formula for inverse proportion is y is k over x, which in other words is a reciprocal graph. So that is b. They're saying it's a trig graph, so I think sine graph, cosine graph, tan graph. Which one do we have? We've obviously already said this one. A, that one's the sine graph, isn't it? Exponential graph, which you actually got in paper 2, the one that just goes up. So that's D. And do you see how then I'd go, oh, okay, well, the last one is obviously C then. Because I wouldn't necessarily know the square root graph. That's not one that's on your list to know, but because you should know the other three, then hopefully be able to get just that one is C. So yeah, 2 marks for that one, recognizing graphs. Now I think you did get, actually technically both of these questions in paper 2. So I doubt that they're going to ask it again, but I'll just go through it really quickly for anyone who might be in year 10 or revising for something else. So we need to show that 2x plus 1 multiplied by x plus 3 multiplied by 3x plus 7 can be written in the form ax cubed plus bx squared plus cx plus d, where obviously a, b, c, and d are integers. So it's expanding triple brackets. Yeah, this is a nice one. So expand the first two as double brackets, 2x squared plus 6x plus 7 plus x, because that makes 7, plus 3. Obviously simplify that before you then bring back the third one, 7x plus 3. Bring back your last one, whichever one is missing, 3x plus 7. And I just multiply it straight across, so 6x cubed plus 14x squared plus 21x squared plus 49x plus 9x plus 21. And obviously then I just simplify it. I expand it in that order because I end up getting all of my like terms next to each other. You can obviously expand it in a different order if you want. So you should get 6x cubed plus 35x squared plus 58x plus 21. There's 4 terms, and that's basically your 3 marks. Part B, I know that you got a question. It didn't look necessarily like this, but this is effectively quadratic inequalities, and I know that you had a question like this anyway. So there's different ways you can actually solve this. You can just square root both sides if you want, or you could expand it, move it all around, you know, that type of thing. I think in this case, I'm just going to square root both sides. The only thing to be aware of when you square root, obviously, a number, so I'm square rooting this, is technically the answer is plus or minus. So square root 9 is 3, square root of 25 is 5. So plus or minus 3/5, not just positive 3/5, because obviously it's a quadratic, you should end up with 2 answers. So I'm just going to solve this. I'm going to add the x to make it positive, and I'll move this across. So 1 plus or minus, I guess, 3/5. So my values for x, obviously I should have 2, is if you do 1 minus 3/5, you get 2/5. If you do 1 plus, you could leave it as a mixed number, or an improper fraction would be 8/5. But you have to memorize or have to figure out how to put the inequality symbol back in. It's either going to be that x is between these two values, or x is smaller than the small one, bigger than the big one. And it's normally dependent on which way it faces. Now, because this wasn't really written in a normal format, as in all on one side, 0 on the other, it's kind of hard to figure out. But if you were to rearrange this, and that's minus that bit, then it's 0. And if I expanded that, I get a positive x squared, wouldn't I? So because it's facing the 0, that means that it is a range. So I would just then go, okay, x is between. If it was facing the quadratic, like if it was facing that way, it would be 2 separate inequalities. But as I said, you've already had this question anyway, so I doubt that they would ask it again. So I'm not too worried about spending too much time on it. So yeah, 6 marks for both of those questions. Okay, upper and lower bounds. This is something that I don't think's come up yet, so definitely feel like they're going to ask something about this. So this time they've just given you a formula straight away. They've said d is equal to u squared over 2a. U is 26.2, correct 3 significant figures. A is 4.3, correct 2 significant figures. Calculate the upper bound of the value of d and give your answer correct to 6 significant figures. So we want the biggest possible answer. So we want the upper bound of d. To get the biggest possible answer when you're dividing, you want the biggest possible numerator, and then you're going to square it, divided by the smallest possible denominator. And obviously you still have to times it by 2, but ideally times the smallest number by 2. So I need the upper bound of u and the lower bound of a. So the upper bound of u would just be 26.25, just chucking a 5 on the end. Don't forget that you are squaring that though. and the denominator I am multiplying by 2. I want the lower bound, so that'd be 4.25. So once you figure that out, it's then really straightforward, just subbing it into your calculator. 26.25 squared over 2 times 4.25. Now remember, they did say 6 significant figures, so 1, 2, 3, 4, 5, 6, but the one after that is a 7, so I would round it up. So I would say 81.0662. 0662. And that's 3 marks already. And then there's a part B. So we worked out the upper bound, didn't we? They've then said that the lower bound for the value of D is 78.6003, correct also to 6 significant figures. By considering bounds, write down the value of D to a suitable degree of accuracy, and you must give a reason for your answer. So looking at both 78.6 and 81, what would they both round to? Sometimes it's the nearest 10, sometimes it's the nearest whole number. Sometimes it's like 2 significant figures, 1 decimal place. You know, it could be any kind of level of rounding. You just look at that particular scenario and you go, right, well, what would they both round to? In this case, I think it's pretty obvious. They would both round to 80, wouldn't they? That would be the thing they round to. And then your reason is, whatever you've rounded it to, they both, you know, agree. So you could say to this one, you could say the nearest 10. You could even say the nearest 5. That would also be correct. You could say 2 significant figures. That's all the same, isn't it, for rounding to 80? I normally say 2 significant figures just because it sounds, I don't know, sounds fancier. But so I would say to 2 significant figures, they both round to 80. That's normally how I word my answer. You can obviously word it differently, just as long as you say something about the fact that they both round to the same number or they both agree. I think in the mark scheme you could say the bounds agree, something like that. That means that they both would round to that. Yeah, that's normally what I write. So yeah, nice 5 marks there. But yeah, hopefully this is something that will come up. I think that's quite a good topic. Question 20. I think we've got 4 more, guys. So question 20. Let me make this a bit bigger. I don't think you've had simultaneous equations either yet, so I'm expecting, you know, something like that to come up. This one is just a straightforward simultaneous equations one, so they've literally just said solve algebraically the simultaneous equations. You can obviously see question 20 and you can see it. One is a quadratic, one is linear. So the way that we solve when we've got quadratic and linear ones, you always have to take the linear one, so the one that doesn't have any squares, and you sub it into the quadratic. But sometimes you need to rearrange it first. You see how this one, we do need to rearrange it. There's no x or y as the subject. So this is where you have to start making some decisions. Do I want to make x the subject? Therefore, I would be replacing the x in the quadratic one. Do I want to make y the subject? And therefore, I would be replacing the y in the quadratic one. There's kind of 2 ways that I decide this. Either if the linear one easily rearranges to x or y, I might do that. Or I look at in this case, because it's not really easy for x or y, is it? So what I would do in this case is look, which one is it easier to substitute into? I personally would rearrange to make x the subject because I would be substituting into just x. Whereas this, well, obviously x squared, but just x squared. This one, I'm not only just substituting it into y, I'm substituting it into y squared, and then beyond that, 4y squared, and then beyond that, minus 4y squared. So you can rearrange it to make y the subject and sub it into y. That's not like it's wrong. It's not wrong. It's just more complicated. And I would rather kind of make my life a little bit easier. So I'm personally going to rearrange to make x the subject because substituting into just x squared is so much easier than substituting into 4y squared. So that's kind of the decision I make. Some people just decide to go, I'm just going to stick with x the whole time. I don't want to make the decision. That's fine. It's not wrong. You can substitute into either. It's not wrong. It's just like I would rather choose whichever is technically easier. And therefore, which one I'm less likely to make mistakes on. So let's rearrange it to make x the subject. Obviously, take away the 4y. Also, don't get mixed up. I know it says 4y and 4y squared, but it's like some people think that that is the same as this. It's not, because it's y squared and then it's times by 4. Yeah, that's fine. You can stick with just one letter the whole time without having to worry about deciding. That's also fine. As I said, either one is correct. It's just sometimes one is harder than the other. Sometimes they're both as easy as each other and then you just pick one randomly. So not an ideal fraction, but if we made y the subject, we'd still have a fraction, so it didn't make much of a difference. So substitute into x, so 7 minus 4y over 3, but remember that that whole thing is squared. Then I've got minus 4y squared, and that equals 9. Now, just be careful when you are literally squaring this fraction, because some people might just square 7 and just square the 4y, but it's not. It's effectively that numerator creates double brackets. So don't forget that there are kind of terms in the middle when you expand that. Obviously, the denominator, you can just square it. That's fine. That's just a 9, isn't it? 9. So I'm going to expand the numerator, 49. So you do get 7 squared and you do get 4y squared, but you also get terms in the middle. You see how I'd get minus 28y minus another 28y. Don't miss those two out. And then that would become positive 16y squared. Now at the same time, I might just multiply everything by 9. So if you multiply across by 9, obviously none of this that I've written changes because it just cancels out the 9. So I'm not multiplying any of this by 9. But what I do need to times by 9 is this and this. So some people miss out. It's just a bit of just so many different trick questions here. Some people miss out multiplying the minus 4y squared by 9 as well. So don't forget that. So that would be minus 36y squared. And it would then equal 81. So I've opened up everything. I've got rid of the fractions. I just did that in one step. You can obviously do it in multiple steps if you want. Now, I might as well tidy up the left-hand side. Let's collect the like terms. So 16y squared minus 36y squared is negative 20y squared. I like to just put the y squared first. Then minus 56y, and then plus 49. Now, as you can see, because it's obviously going to be a quadratic, what I want to do is have all of my terms on one side of the equation to then solve it and have, obviously, the other side of the equation be equal 0. So you might think, oh, I'm just going to move it across because 81 is the easier one to move across. It's only one term. What I tend to do is that I just prefer to have my y squared or x squared or whatever it is, the squared one, as a positive. So I personally am actually going to move all of that across. Now, what you can do is obviously move the 81 across and then just times by negative 1 to make it positive. If you're comfortable with doing that, that's fine. I just prefer to kind of move things around. So I'm actually going to move them all to the right. So that would be add 20y squared, so it becomes positive. Add 56y, positive, and then take away 49. So that actually leaves me with 32. Now, you can actually factorize this, but because it is a calculated paper, if you don't want to factorize it, you can also use your quadratic formula. That's fine. They haven't specified, so you can use either. I think I just factorized it, to be honest, because not like this, but do you see how what you can do is simplify this. You see how 20, 56, 32, they're all multiples of 4. So if I'm going to factorize it, I would at least try and simplify it first, right? Because I don't really want to deal with such big numbers. So I've got 0 is 5y squared plus 14y plus 8. And that's a lot easier to factorize. But as I said, you can just chuck it into the quadratic formula if you like. That's up to you. But if you factorize it, you get 5y plus 4 and then y plus 2. It's all positive, so it was fairly easy to factorize. And obviously solving that, you get y is negative 4 over 5, or 4/5, or 0.8, or negative 2. Now that's the hardest bit, isn't it? All of that is the hardest bit. You obviously then want to find out whichever other letter you didn't find. In my case, I didn't find x, so now I want to find out x. So you substitute both of those values into the original equations. Now, obviously, you can sub it into the quadratic one. I just don't see why you would. Hang on, you don't get the last part. The bit I've just said, or the bit I'm about to do? Because the bit I'm about to do is like the last part. Or do you not get what I just did? Because I can go back through it. The bit I'm about to. Oh, this is the easiest bit, this bit. If you can do all the rest, you can do this last bit, I promise. So, this also is the same for, when you have both linear simultaneous equations as well when they're just like question 7 or something in the paper. Once you found one of the letters, so in this case I found the y, you then go back and you choose out of your 2 original equations, which one do I want to substitute my values in. Again, it doesn't matter which one. I again would just choose the one that I think is easier. In this case, obviously the linear one is normally easier, isn't it? You can use the quadratic one as I was saying, but I just don't see why you would. Now, not only will I choose the linear one, I'm actually, in this case, specifically for the quadratic linear versions, I'm actually going to choose this. Because this is the same as the linear one, isn't it? I've just rearranged it. And because I'm going to be trying to find x, I might as well use the version of it that already has x as my subject. So this is still the second equation, it's just rearranged. So I'm going to take this, right? That's my second equation, it just happens to be rearranged. So x is 7 minus 4y over 3. Let me try and remember that. 7 minus 4y over 3. So x is 7 minus 4y over 3. Obviously try and copy it properly. Do you see how, because I know what y is, I can just substitute that in? So like replace this, and obviously I have to do it twice, okay, in this case, because there are 2 options. So replace it with, first of all, the minus 4 fifths. Obviously, put it in the calculator. 7 minus negative 4, well, 4 times, I guess, negative, I'm just going to put 0.8, but you can put the fraction in, over 3. I'm going to leave it as a fraction. You could obviously put it as a decimal if you want, but I'm just going to leave it as a fraction, is 17 over 5. So that's the other x value. And then, obviously, or you need to do the same with the 2, the minus 2. So 7 minus 4, where it used to say y, I'm going to substitute in minus 2 over 3. And you can just go back and change this. And then get 5. So then do you see how I've got 2 y values? Because it's a quadratic one, you should have 2 of each. And 2 x values. The last bit is really straightforward. If you can do the rest of it, once you found one set of values, so the y or the x first of all, you then take those and sub them into one of the original equations, whichever original equation you want to use, doesn't matter which, as long as it's, one from the top of the question. And that's, this second half of this method is the same for the linear ones as well, the ones that are at the start of the paper. So yeah, exactly. If you can do all the rest that was so, to be honest, like really complicated, if you can rearrange all of this correctly, all of this stuff, then you can definitely do the last bit. 100%. Yeah. So yeah, that's a nice 5 marks, I think, that one. Obviously you would list it on the line, I just don't have space on my one. Okay, histograms. I know that you did have also a histogram question in, I think, paper 1. So I don't think they would ask histograms again, but I mean, I guess we never know, technically. This one actually, if you look at the second page, is a pie chart one as well, so that might be kind of interesting to look at. So the histogram gives information about the distribution of the weights of some onions grown by a farmer. Onions less than 60 grams in weight are used for pickling. So like basically just this bar here, isn't it? That's the pickling. And then onions greater than 120 grams in weight are sold at the market. So this bar, but also this kind of bar here. And colour it in. And then the rest of the onions, so these 2 in the middle, are then sent to a food processing factory. So let me just get the question quick. Then we'll go back and obviously look at the actual histogram. A pie chart is drawn for the information opposite. That obviously in your, when you print it, it'll be on the opposite page for you. You'll be able to look at them both at the same time. Yeah, a pie chart is drawn using the information opposite to show what the farmer does with the onions he grows. You can see some of them are used for pickling, sold at market, or sent for food processing. The angle of the sector for the onions sent to the food processing factory is x. Work out the value of x. So we need to find what kind of portion of this pie chart is the ones sent to the food processing factory, so that's the ones in the middle. So I'm just going to have to work out the frequencies of all of them, aren't I? That's effectively the first thing. You obviously might know that you just multiply them together, but If you don't, you can obviously use this formula triangle. We're looking for the frequency. So yeah, both axes multiplied together. So the green one, 2 times 60, 120. Then the next one, we've got 5 times 30, which is 150. Then we've got 9 times 30, which is 270. And then this one, just be careful like with what this one is. I know I've kind of drawn on it. That's 150 there, that's 120. So that I would say is 15 width, as in that's 135. But the class width is 15. So 6 times 15 is not what I was thinking, is 90. And then this last one is then 15 plus another 30. So that's 45, isn't it? Just be careful of those class widths. 2 times 45 is another 90. Okay, so if you add them all up, the total frequency is 720, but the bit that I want is the food processing factory bit, which is the 2 in the middle. So what was that? These two here, wasn't it? And if you add those up, you get 420. So out of all of them, 420 out of 720 are going to the food processing factory. And then because it's a pie chart and we're looking at angles, obviously angles around a point are 360. You can just times that by 360. Because this is your kind of portion, isn't it? This fraction here. And then it's out of 360 degrees. Over 720 times 360 gives me 210. So that would be my angle, literally 210. Here. Obviously you would write it in this box here. So 210, that's the value of x. You can just about see that is 4 marks. So maybe the pie chart might come up. It doesn't come up that, that often, but maybe. Okay, this is quite an interesting one, I thought. I know that you've technically had a circle graph, so I don't know, how likely it is that they'll ask another circle graph, even though this one's kind of more so, it is a circle graph, but then you've also got the tangent, you've also got angles. It's kind of different. So I don't know if they would kind of overlap those two topics. Because I know yours was just like a translation one, wasn't it? Drawing the graph and then translating it down, something along the lines of that. So I don't know. They might not bring it up again. We've got here, the diagram shows a circle centre O. AB is the tangent to the circle at point A, as you can see. They've given us the angle OBA is 30. The point B has coordinates 16, 0, so that's obviously like this bit here, isn't it? And then a point P has coordinates 3P and then P. Find the value of P. So, okay, so I was thinking with this one. Yeah, what I was thinking was they've given me an angle, right? So I'm thinking it's got to be something to do with some version of trig. That was kind of my first thought, because they've given me an angle. And I can definitely... I wasn't really thinking sine or cosine rule, because I was like, I could definitely create some right angle triangles here. But how do I relate it to... I kind of backtrack it sometimes. I go, right, to find P, and 3P obviously, is finding the coordinates of P, isn't it? To find the coordinates of P, you need to have the equation of the circle, because it's obviously on the circle, isn't it? So I need to have the equation of the circle. So then I'm thinking, like, again, backtracking. How do I find the equation of a circle? Well, I know that it's based around x squared plus y squared equals the radius squared, because its centre is 0, so that's fine. So technically, all I need to do to find the circle equation is find the radius and obviously then square it. So how can I find the radius, and how would that relate to the fact that they've given me 30 degrees, the fact that they've given me this 16 number here? The line that I drew was from the centre to the circumference where it touches the tangent. Because, first of all, that's a radius, isn't it? That's a radius. But second of all, if you think about circle theorems, I know that the radius and the tangent is 90 degrees. And then I've created a right angle triangle with 30 degrees, the radius that I want to know. And technically, if I know point B is 16, then this side length is 16. So do you see how I just kind of pieced all of that together by backtracking a little bit? So I thought, oh, okay, that's fine. That's basically just a right angle triangle. I've got one side, I've got one angle, and I'm looking for another side. So it's just normal trig, just SOHCAHTOA, but in a really complicated context, isn't it? What grade is this? I don't know. This is question 22. How many questions are there? There's 23 questions. So this is the second to last question. So I would say, yeah, this has got to be like up there in the grade 8s, 9s, hasn't it? Surely, because this is right at the end of the paper. It's not that the maths is necessarily complicated in this one. The calculations themselves aren't that complicated. What is complicated is figuring it out in the first place, isn't it? That's the problem. So I've got this. Now, obviously, using normal trig, label the two sides that are relevant. This one here is the opposite. Try to be careful with this because I know it doesn't look diagonal because obviously it's the way it's rotated, but this is the hypotenuse, isn't it? So just make sure you do label it correctly. SOHCAHTOA, we're using sin, obviously, looking for the opposite. So I need to do sin 30 multiplied by 16, which, if you remember earlier, I mean, obviously you put it in your calculator anyway, but it was a half times 16, so that's basically 8. So the radius is 8. So the radius is 8, and then therefore my equation is x squared plus y squared is 8 squared, and I want to find p. Yeah, the live will finish once this paper is done, yeah. We've just got this question and then one more, and then it'll be finished. Because I'm looking for p, and luckily both coordinates are in terms of p, it's the same letter. If I just substitute those in, so that's 3p, all of that squared, plus just p squared, is 8 squared. You see how luckily I've got an equation with just one letter? Even though it was representing two coordinates, the letter was the same, wasn't it? So I just need to solve that. So if you square that, you get 9p. Don't forget to square the 3 as well. 9p squared plus p squared. Obviously, might as well square the 8. 64. Add that together. 10b squared. You see how I can just solve it now? So divide by 10. P squared is 6.4. Square root it. Grab my calculator because obviously you want the calculator for that. And you can see they have said give your answer correct to 1 decimal place. Now, I know that before I said when you square root things, you obviously get technically plus or minus. I know it obviously only shows you the positive version in your calculator. Technically it is plus or minus 2.5. But, so what was that 1 decimal place? Yeah, 2.5. Technically it's plus or minus 2.5, but I'm obviously going to choose one answer. And I can choose that because if you have a look at where the coordinate is, it's in the positive section, isn't it? It's not over here in the obviously this bit would be like the negative version, wouldn't it? We're looking for the positive one. So in this case, because there's a context, you can ignore the negative scenario. So your actual answer is the positive 2.5. So yeah, I don't know, that one I think, the maths isn't that hard. The problem is figuring it out initially, isn't it? That's the issue. That's the risk with that one. And then the last one, make this a bit bigger as well. Bearings. Bearings doesn't always come up, but it hasn't come up yet. So, you know, there's a chance it could come up, or they might just not bring it up at all. So this one might be hard. Again, one of those ones where initially you're like, I've got no idea how to do it. But once you see how to do it, and you know that this is a possible scenario going forward, then I think it's not too crazy. I mean, obviously we're still working grade 8, grade 9 stuff here, but once you know what to do, I think you go, oh yeah, that kind of makes sense. So the diagram shows the positions of 3 towns, Acton, Barston and Chorlton, obviously A, B and C. They've also, not only have they given us bearings in terms of, both of you are kind of on the right lines. Not only they've given us angles, so bearings, they've also given us side lengths. So yeah, I'm thinking of a triangle here, definitely. So they've said Barston is 8 kilometers from Acton on the bearing of 0.37, and Chorlton is 9 kilometers from Barston on a bearing of 150. You can obviously see that. Find the bearing of Chorlton from Acton. So this is the hardest bit because you've got to figure out, first of all, what actual angle is that. I think that's probably the hardest bit to figure out. So it's always the one from, as in, where's my pen gone? From Acton. So I'm going to go from the north line of Acton to Chorlton. Now that obviously means, as you said, create a triangle because I want to draw a line between Acton and Chorlton. There. And you see I've now got this scalene triangle. So my angle is technically all of this. Make that a bit bigger. Now obviously I do, no, that was horrible. Try again. Okay, that's not getting any better. We'll just go with that. My angle 37 I already know. So all I'm missing is then like this bit here, which is then inside the triangle. So yes, we're thinking a triangle. Now what you were saying about alternate angles, you're kind of right. So currently I've got two sides of my triangle. Great. Well, I haven't got the angle, but I'm looking for the angle. Because this is a scalene triangle, right? Just like a random triangle. It's not a right angle triangle. I'm thinking it has to be sine rule or cosine rule, because we've got a mixture of angles, a mixture of sides, haven't we? So that's obviously trig, but what type of trig? Also, we just did SOHCAHTOA in the previous question, so they're not going to ask it again, are they? So I'm thinking, right, sine rule or cosine rule. The thing with sine and cosine rule is you need, technically, I say 4 pieces of information, but that includes the one you're missing. So do you see how I'm missing this angle? I've got 2 sides. That's only 3 things. So I need something else. Either another side or another angle. And that's where you were saying about the alternate angles. Not necessarily alternate angles, but the north lines are parallel lines, aren't they? Obviously, they're all pointing to north, and that's the same location. So those are parallel lines. Those are parallel lines. So I'm going to use that. What I thought was, okay, not alternate angles, because that's the Z one, isn't it? And I don't have any Z ones here. But the co-interior angles. So if this is 37, then I could work out this one here, couldn't I? Co-interior angles add up to 180. So if you just subtract that. What should we get? I think 143, is that right? 143, let me check on my calculator, 180. Yeah. So this one's 143. And then, because, again, that's not inside my triangle, but angles around a point, I could work out then this one that's inside the triangle. So yeah, if you think bearings, do consider that maybe it would overlap with parallel lines. They don't necessarily tell you that they're parallel, but it's kind of implied, isn't it? So obviously 360 minus both of those, plus 150, gives me 67. So now I have an angle inside the triangle, and I have 2 sides and another angle. Okay, now, if you look at it though, I've got 2 angles, 2 sides. So that's normally sine rule, isn't it? But the problem being is they have to be opposite. Do you see how, yes, okay, that one's opposite the 9, so that's fine. But my problem is this one is opposite a side I don't know, or the side I do know is opposite an angle I don't know. So I don't have enough currently to use sine rule. So yeah, when you said cosine rule, that's what I'm going to start with. I'm going to use cosine rule because cosine rule is 3 sides, 1 angle, isn't it? So that to me, and obviously the angle between the 2 sides, you know. I could work out the side AC using cosine rule, which I know doesn't tell me my angle, but that's kind of before I get to that point. So cosine rule, again, if you want to change it to make them, what is it? Cos A, if you want to change, you know, the angles to match, then that's fine, to match the formula. You can do that. Obviously, it's on your formula sheet anyway. So a squared, I'll just write it here, is b squared plus c squared minus 2bc cos A. So obviously the angle we're using is 67 because that's the one we know. We're looking for AC squared because that's the one opposite the angle. So the other 2 sides, it doesn't really matter which is B and which is C, just sub them in however you want. 8 squared plus 9 squared minus 2 times 8 times 9, and then times cos of the angle 67. Obviously then square root. So let's type all of that in. 8 squared plus 9 squared minus, now I normally type it in slightly differently to my calculator like this, with just one big bracket basically, times 9 times cos 67, close both brackets. Now obviously that's the squared one, isn't it? Just remember, if they're 8 kilometers, 9 kilometers, it's not going to be 88 kilometers, is it? So do square root your answer. So I've got 9.42 kind of ish for AC. That makes sense. It's kind of in the same ballpark, isn't it? 9.42. So now I have this. Do you see how now, yes, back to this, we do have the opposite angle and side here, as in the one I'm looking for. And now I have 67 and an opposite side. So now I can use sine rule. They have to be obviously not only 2 pairs of angles and sides, but opposite. Yeah, exactly. So a lot of the time I feel like I know you've had sine and cosine rule already, so I feel like it's probably not going to be asked again. But just in case, because I don't think you've had bearings as such. Yeah, they have to be opposite as well. So sine rule, I'm looking for the angle, so that's the one that goes on the top, isn't it? So sine of the angle, you could call it x if you want, or BAC, or whatever you want to call it, over the opposite side, which was 9, is equal to sine of the other angle, I have 67 over the opposite side. 9.42. Yeah, and then obviously from here I'm just solving, right? So I do need to multiply across by 9 to get sine of the angle as my subject. Is 67 over 9.42 multiplied by 9, and that you just now chuck in the calculator. The only thing though is because we're looking for an angle, you always, whether it's SOHCAHTOA, like basic trig, or whether it's this type of trig, which is more complicated, if you're looking for an angle, you always want the inverse function. So you know when it's like -1. So I'm just going to straight away do that. You can do it in 2 steps if you want. You can do it in 1 step. I also still have my answer here. I know I wrote down 9.42, but I'm going to try and use this answer to get all of the decimals and try and keep it as exact as possible. So sine inverse of all of this. So obviously normal sine for the 67 because I've got the actual angle. Over, now that's the 9.42. I'm just going to write answer because then I can have an actual specific number. Times by 9. Then I've got an angle straight away. So what have they said? To 1 decimal place, 61.6. 61, that's not 61, that's 6.1, 61.6 degrees. Now, I feel like this happened 3 times in this paper. You've done all of this working, you feel like that's the answer, but it's not. Remember what we were looking for, this pink angle. So what we've worked out is this. But just remember that last little bit, I need to add 37. Because otherwise, yeah, we'll lose that last mark, unfortunately. So yeah, always double check. Once you feel like you finished a question, just double check. What was the question again? Because I don't want to miss out the last step when it's so easy. So add the 37. Again, 98.6. We just already rounded it, didn't we? Now, because it's a bearing, technically, because it's ignoring the decimal, the first 2 digits, normally they have to be 3 digits before the decimal place, so put a 0, but I don't think they'd mark you down if you didn't put a 0, but just technically, because it's bearings, 098.6. So yeah, it's just one to be aware of, that they can combine bearings with sine and cosine rule. You might not have thought that they could combine those 2 together, but they can do. Can combine sine and cosine rule with almost anything where you can create a triangle. But you've already had sine and cosine rules. I'm hoping it won't come up again anyway. We just don't know. But yeah, obviously that was a 5 marker. That was the last question on the paper. So yeah, overall, I guess a fairly nice paper. The last 2 questions were a bit kind of difficult, but yeah, good to look at. So yeah, if anyone has any questions, please leave them down below in the chat. Otherwise, if no one has any questions, then I will finish this live here. And I will be doing one tomorrow as well. That one will be, because we're working backwards, what will that be? Probably the November 2018 paper, obviously one of the calculator ones. Yeah, thanks for joining me. Hopefully you found it helpful. Tomorrow my predicted paper that I've written will go live as just like an actual video, not as live, it will just be an actual video, so you can have a look at my predicted paper tomorrow if you want. Yep, thanks for joining me guys. I'm just going to leave the live here then.